Okay, good afternoon. Welcome to another video. So in this video, we're going to talk about the balance search tree deletions. Um, we are going to concentrate on uh, red-black tree because the binary search tree and the 2-3 search tree is pretty straightforward. So we will be concentrated on, going through the red-black tree deletions, which is, pretty complicated. So, uh, we talked about the inserting a node into the, you know, the red-black tree last time. We only had what, four different cases that, which the first two was pretty easy. So we just had four different cases to inserting the node into the red-black tree. But deletions is pretty, I don't know, there are lots of conditions that, cases that we need to go through. So we'll, pay a lot of attention to that one. But let's just go through the how would you delete the in binary search and the 2-3 search. The binary search tree is that if you want to, let's say, for example, you want to delete the node 12. So that means, let me just grab my pen over here. So for example, if you want to delete the node 12 here, what you need to do here is that you're going to look at the leaves, okay, leaves at the bottom. Then you want to go to the all the way to the rightmost node. So starting at root, okay, find the deepest and the rightmost binary tree node. Okay, and then we are going to replace that rightmost node's data with a node to be deleted. So in this case, rightmost will be a 9. So whatever the 12 you had, 9 is going to get replaced. Okay, so now you no longer see the 12, you see the 9. And then you're just going to get rid of that 9 because you already replaced to the place of a 12. So then you don't see that, that 12 node anymore because we just deleted. So that's how the binary search tree deletion works. Pretty straightforward, right? 2-3 search tree is pretty much the same way as you are inserting the node. So if you go through that process of insertion, deletion is exactly the same way. The red black search tree is going to be the one that we need to pay attention. Okay, now, as I mentioned, there are many cases and many conditions that we need to go through on the red black search tree deletions. But rather than going through the all the cases, what we're going to do here is that we are going to go through an example, and whenever that initial steps or properties that we need, we're going to get that from here. Then I'll explain it. Okay, so the first thing here is that we're going to have to look at these two initial steps here. So there are a bunch of steps over here, and then there's another steps over there. So this is going to really, you always have to pick one from each steps here. So once you pick the one step, one of these three, then you go down here and you're going to pick one of these three. I mean four, I'm sorry, okay? So the first thing that we are going to do here is that, we're going to have to find out which conditions that we are in from these three steps. And once we determine that, then we're going to come down here, then look at the full steps over here, then we're going to choose whichever steps that we need to take, okay? So those are the initial steps. Pick one from each category there. Now, Here is the cases. Okay. Now this one I probably will come back because when we use these cases, these cases are a little bit involved. In other words, that the cases that we are talking about here, okay, this is the when the deletion is more complicated than the straightforward. So what we're going to do here is that we're going to come back. This is the same thing, by the way, cases 0, 1, 2, 3, 4. And we'll come back to whichever cases that we're going to need. So, maybe case 0, case 1, and the case 2. So we have different cases that we need to go through, depending on the problem, by the way. Okay. So case 3 here, and then we have another case 4. So rather than just reading each cases, and picking the conditions from the initial steps, what we're going to do here is that when we go through the examples, and then I will introduce, which initial steps that we are going to take, and therefore which cases that we're going to need. All right. So it will be much easier for us to go through an example and just look at the conditions and the steps here. So we do have a red-black tree here. Now it might not be the, it may or it may not, satisfy the definition, but that's the whole thing, because since it's not satisfy the definition, we're going to have to do something, right? But in any case, we will talk about that in a few cases later. So let's say we have the red-black tree, as you see here. We want to delete 6. So, this is what we want to delete. Where are we? Oops, what happened to my pen? There you go. Okay. We want to delete this node here, 6. Okay. So the first thing we're going to have to do is that, okay, now we had the initial steps. Now, which condition are we in from that initial steps? Okay. So from that, there are two categories. First category of the initial step here is that if the node, let's just look at this one here. If the node that we want to delete has 2 nil children, which it is, we want to delete the 6, but we don't have any children. They are nil, right? Right here. Okay. And its replacement x is nil. So now what we're going to do here is that we're going to add something called x, and we're going to then we're going to call the something called replacement, and that's what you see here. Okay. So what the condition saying here is that if the node that we want to delete, has 2, nil children, no children. If the node has no children, and then its replacement x is nil. So what we want to do here is that we want to put the x on the right-hand side of that node that we want to delete, and we're going to point them as that's going to be the replacement. And then we go to the second step. So this is going to be a second category of the initial step. So if the node we delete is red and its replacement is red or nil, then we are finished. Okay, so if you go back to the node that we want to delete, okay, is the red, okay, just like what we said here, and the replacement is either red or nil, which is a nil, then we are finished. Okay, so all we're doing here is that we're going to replace that 6 with the x, and then we are done. So this is going to be almost the simple case that you can see. Okay, so that's going to be the first example. So if you have, just the lift node, and with the no children, all you have to do is just get rid of that node that you want to delete, and you just put the x as the replacement. Okay. Okay. Now, next situation here is a little bit more complicated. Okay. So here we go. So this time we want to delete node 1. So this is what we want to delete now. Now this is going to be a little bit more complicated because even though we have the one of the children is null, the other one is not. Okay, so one of the children is a nil node, but the other one is kind of connected there. So from the initial steps, first category, if the node we deleted has one nil child and the one non-nil child, this replacement x is on the non-nil child. So if you look at this one, now remember that this x is going to be the replacement. So we are going to put this x replacement to the node that you want to delete. And this has to be on the right child of the node that you want to delete. You're going to put the x, okay, to the right child of the node that you want to delete. Now we're not deleting node 6, we are deleting the node 1. So the condition says that if that's the case, you go to the child, okay, and then not the nil side, no, nil, but the which has the child, then you put the x replacement there. So that's going to be the first condition. Now second category is that if the node we want to delete is a black and the replacement is red, we color the replacement black and we are done. So what we're doing now here is that, well, you know what, the node that we want to delete is 1, which is a black, okay? And the replacement is going to be a red. Remember, this is a replacement. Let me just write that over here. The replacement. Okay. I think I wrote it up there, but not here. So that's the condition that we are in. So what we are doing here is that we're going to get rid of this. We're going to delete this one. And replace that node with a 6, which is a red, and make it black. Okay, so let me just look at that. And that's what you see here. Hang on a second. Okay, and that's what we did. Okay. So that one's not bad. If you have the one of them is a child and the other one is a nil, then all you have to do is delete the parent node with the child node and change the color there. So that was pretty okay. So far, right? So now next thing is going to be the one that is going to be a little bit more complicated here. So this time we want to delete 17. This guy over here. We want to delete 17. Okay. So let's just look at these two cases again. The initial steps of 2 categories here. So if the node we want to delete has 2 non-nil children, so that will be, I'm just going to color this with the yellow here. So we have 2 non nil children here. Okay. If that's the case, then we're going to set x, which is going to be the replacements, right child before the replacement is spliced out. So what we're saying here is this. You have to be careful though. Okay. To determine the replacement, okay, oops. We always look for the successor. And now we want to delete this one here. We have a 2 non-new children. Okay. The one that we are going to put the replacement is going to be successor over 17. So 17, in other words, that what number do we have after 17 on this tree? And that's obviously 22 there. 22 comes before 25. Okay, so that's going to be our replacement there. Okay, so the successor over 17, this might be confusing, but all right, just from 17, as you ascend, as you go up, the first number that's going to be detected will be 22 in this area here. It's not going to be 25. 22 is before 25. And 27 is, 22 is before 27. So 22 becomes the successor of 17. And that's going to be our replacement. We're going to put the x over there. Okay, so that's what we have. If the node over here, if the node that we deleted is red and the replacement is red or nil, and then we are done. And what it means here is that since the 17 is red and the replacement is red, we don't have to do anything because we're just going to replace that number there. Okay, so as you can see that 22 is gone. Now it's being, the 17 is gone. And this will be replaced by 22. Okay, and the x, okay. Now remember the x is not the replacement. And the x is going to be the, indicating what will become next. Okay, so we do not define x as any one particular value, okay, but it's more like kind of directions of the operations that we are going. So in this case, 22, we put the replacement into 22, right? And we put the x to the replacement's right child, and that's what we did here. Okay. And x is going to be just simply the indicating the procedure of these operations. Okay, and the where would be the next, so it's kind of giving you some direction of the where this the neo child is going to be. So since the 22 is going to be moving to 17, then you're going to have x neo value there. So, and that's why you see put the x values there. Now, in the first case, well, not a first case, but case before this one, right? We put the replacement itself, right, to the right child, and when we move the x, the child to the parent position, x came along and still there, the x. It's just gonna be it's not. It doesn't have any meanings, but it's kind of make sure that what we are doing, and it kind of what do you call the simply, X is telling you what we have done so far, and then what we're going to do is kind of keep, tracking what we are doing in these operations there. Okay, so this was a little bit, involved. So let's just go back and one more time to when you want to delete the any node with the two non-new children. Okay, we are going to find the replacement, and then when you want to find the replacement, we're always going to look for successor of the node that you want to delete. So successor simply means that whatever it comes next after the in this case node you want to delete, and once you find that successor, uh, you're going to put the node as a replacement, and if it doesn't have any children, we're going to put X in there. And then if they have the same color, okay, with the replacement and the node to be deleted, then we're just going to swap the numbers, meaning that whatever the number that you want to delete is gone. Now it's going to get replaced by the the successor. Since they are the same color, we don't have to worry about doing anything else. Okay, so that's what the this case was. Okay. All right. What about next one? Let's say we want to delete 25. So 25 is right below 17 here. So here is the 25 we want to delete. So if you go to the initial steps that we went through, first category is as if the node, okay, we want to delete has a two non-new children. We're going to find out, okay, set X to the replacement, so right child before the replacement is spliced out. So we have 25 here, so the successor of 25 is going to be the 27, right? And that's why the 27 is going to be our successor here. And we're going to put that as our replacement. And since the 27 doesn't have any child, we're just going to put the X on the right-hand side of that child here. The second initial step, the second category of condition was that if the node we want to delete is a black and the replacement is red, and that's what we have here, right? Because the node we want to delete is a 25, but it's a black node. We want to replace that with the red node. We're going to color the replacement and black, and we are done. So we don't have any other additional operation that we need to do here. So we are going to replace that with a 25 with a, replace 25 with a 27. Now, since the 27 is going to be replacing 25, X is going to be still child of a 27. And after we replace the 25 with the 27, we're just going to recolor 27 to black. Okay, and that's what you see here. Okay. Well, it's not bad so far. I don't think any any complications of doing the operation even with the two non-new children. Because the we happen to have some the colors coding color of nodes are pretty red, no, so we didn't have to worry about it. They just have to, recolor them. Okay. Okay, now let's look at the next one. This time, we want to delete node 18. This one's a little bit complicated here, so we're going to look at this one a little bit more carefully. So now if you go to the first initial steps, first category, if the node we want to delete has two new children, set X to the replacement's right child before the replacement is spliced out. Same thing. So if you look at the 18, okay, the successor is going to be 22, right? So we're going to put the 18, okay. We're going to child of 18, the right child of 18 is going to be 22. So we're going to put that as our replacement. Then we're going to put the X to the right child of that 22. Okay. All right. Now the second initial step condition, second category of the initial step is that if the node we deleted is red, which is the case, which is 18 is the red. And the its replacement is black. Color the replacement red and proceeded to the appropriate case. So in this case, okay, the condition, the second category of the initial step saying that now if you want, the nodes that you want to delete it is the red and the replacement is black. Okay, we're going to swap we're going to get rid of 18 and we're going to put 22. Then we're going to color the red 22. Then we're going to go down to those 4 cases that I mentioned. Case 0, 1, 2, 3, 4. Right? So we are not finished. Okay. So let's just do the second steps. So we are going to replace, okay, 18, red 18 with the black 22. Then we're going to color to red, and that's what you see here. Okay. We replace the red 18 with the black 22. Then we change the color to red. So now we're going to have to look at the what case that we have here. Okay, so let's just go up. I didn't write it over here, but let me see. So we have there are 4 cases that I asked, I told you that we're going to go through. But let me just go here and what the case 0 was. Okay. There we go. So in this case, the case 0 is that, if the color X black, and then we are done now. Okay, node X is red, right? So what we did here is that, this was the condition that we finished, right here. Okay. Then we're going to move to the appropriate case. Okay. Oh, okay. So that's what we did here, I think. So we are going to the case 0. Then we're just going to say node X is red. Okay, so let me just go down there. And we are going to finish that. Okay. Did I come? Oh yeah, here we go. Okay. So if the node we deleted is red, replacement is black, color the replacement red, and then we're going to go to the case 0. So what we're doing here is that we are going to color X black. See right here? Now remember, this is why the X is important. Okay, so X is now at 26. So if you don't put the X in the appropriate steps or places, then everything's going to be wrong. So we're going to color the X black, okay, right here. And then we're done. Okay, and that's right here. Now, okay. So we have to be careful though, because it doesn't look like a red-black tree is a violations of that red-black tree properties here. So in this case, once you change the color of 26, in this case X, to the black, and then 3 here, you can just change that to red without any problem, because you don't have any children there. Okay, so that's no problem. I just didn't color red, but that's what you're supposed to have there. So then it satisfies the properties of the red-black tree. Okay, so maybe you should draw another tree with the 3 with the red. Okay, so now this time we want to delete, we want to delete the node 2, this one here. Let's just go through the first 2 categories of initial steps. Okay, so let's just take a look at the first one. If the node we want to delete has 2 non-new children, we're gonna set X to the replacement's right child before the replacement is spliced out. So it means that we want to put replacement 4, then we're gonna put the X in there. And the other second category of the initial step is that if the node we want delete is red, and the replacement is black. That's what we have here. The replacement, okay, red, and proceeded to the appropriate case. So we're going to replace that 2 with a 4. Okay, I'm just going to show you the diagram down here. Okay, so we want to call this guy number 4 our replacement. Okay. And then we're going to put the X to the child, right child of replacement of 4. And then we are going to replace the 2, okay, with the child of 4. Now remember that X, now the X is no longer there for, a node 4. So it automatically goes up to 2, but 2 is going to get replaced with the 4, right? So then we're going to replace that color to the red. Okay, so that's what you see here. So this is going to be a bit more complicated here. So what we did here is that, we replaced the 4, but the condition says it has to be replaced that with the red color. Okay, So here's what we have here. So once you finish that, we're going to have to look at the one of those four cases. Okay. So this becomes the case number 2. Okay. So okay, let me see. We want to go there. What case number 2 is? Okay, because we don't know which case that you need to select. So maybe we should go over those 4 cases there. Okay. Let me see. Okay, so let me just go through these 4 cases because we are doing the problem based on this. So case 0 is going to be node X is red. Okay, I mean, that's pretty obvious, right? Then we're going to color X black and we are done. And if the node X is black and there's a sibling W is red, then we're going to color W black, color X dot P red. P means the parent. And then rotate X dot P and so on. Okay, so I think this is similar to the what we did on the inserting, you know, the red-black tree there. So case 1 is get a little bit involved. We'll, I don't think we went through that one. We did go through the case 2 a few minutes ago. So node X is black and its sibling W is black, and both of W's children are black. Okay, so we're probably going to have to go through these cases now. Remember that you only come down to these cases, okay? You don't come down to these cases, based on these initial steps. So there are 2 places that you're going to end up coming down to these 2 cases. Is the one I just explained there. If the node we delete is black and its replacement is nil or black, proceed to the appropriate case. And the other case was if the node we deleted is red and the replacement is black, color the replacement red and proceed to the appropriate case. So the initial step, first category, we don't go to these one of those 4 cases that we have, but once you go through the second category of the initial steps, then you may or you may not go down to one of these 4 cases. So the example that we are doing right now, I think, is the second one here. If the node we delete is red, and the replacement is black, color the replacement red and proceed to the appropriate case. Okay, so that's what we have now. So, we have cases here. So the one that we are doing here, we are doing, I think, the case number 4. I think so. Okay. Node X is black and its sibling W is black. And if X is the left child, W is the right child is red. If X is the right child, then W is the left child is red. So let me just go back. So which cases that we are doing here for the last example that we have. So hang on a second. I'll come down here in a minute. Okay, so give me a second. So this example, all right. Okay. I mean, am I down here too far? Oh yeah. I'm over here. So if you look at the case that we need to choose is that if node we deleted is red, which is true, and then we color the replacement red, then we go down to the appropriate case here. So in the case number 2, the node X is black. Now remember that I had to replace the I mean not replace, but I have to assign, okay, W in this case, okay. So what I did here is that, since the 4, we need to take care of this, the node 4, and X was the child that we marked as an X. So we're going to mark to the left child with a W, and that's what we said here. So node X is a black, and that's what we have. And its sibling is also black. Now, even though I, put the green, maybe I should not do that. I'm just going to put it, you know, black over here. Okay, so you don't get, hey, that's green, So here we're going to have a, a W and here X. So that's what we're saying here. Node X was a black, although I wrote it as a green, but that's supposed to be black. And the sibling W is also black. So this is a sibling. W is a sibling of X. So that's the case that we are in. And they are both W's children are black. Okay, so right here. Okay, here's a W here. It's kind of slow. Okay, here's a W, and they both, Neil means a black, right? They both are black there. So what the step here is going to be now, once that has been determined, that the W is black node, and its children's are the also black node. That means we're going to color with W with the red. Then remember that the X is the sibling of W. So we're going to set X equals to X dot P means the parent. Okay. So we're just going to move the X from the children to parent. If our new X is red, okay, color X black, and then we're done. Okay, so that's after you color red. If our new X, now remember that X has to go to the parent, right? If our new X is a black, decide on case 1, 2, 3, or 4 from here. Okay, note that we have new W now. So we have to find that out. So when we we are going to replace, okay, we're going to color the W red, which I did here. And then I put the X to the parent, and that's what I did here. Okay. If our new X is red, which it is, it's a full red, then we want to color this guy, the full black, and we are finished. And that's what we did here. Okay. We are not going down to the B over here because, that's not, pertain to this problem here. So see if the X is red, then we're going to color the black, and then we are finished. Okay, so that's what diagram looks like. Okay, so even though we have the condition B, that's not for this problem because the the node that, x dot p is, red, not the black, so we don't have to go down there. So this one is a little bit more involved, but as long as, you follow these directions, you're probably going to be all right. Okay. Let's look at the another problem. Okay, so here we want to delete 8 over here, this guy. So let's just go through the initial steps. So if the node we deleted has a 2, okay, new children, which is a true, right? Then we're going to set x to the replacement's right child before you splice out. So you look at the 8, then you look at the right child, okay, and then we're going to set the right child of replacement with x over here. Okay. Second category of the initial step is that if the node we deleted is red and its replacement is black, which is the one we have right now, because 8 is red, we're gonna delete that, and the replacement is gonna be 11, which is a black, right? So color the replacement red, and then proceeded to the appropriate case here. So we are going to delete 8 now. 11 is going to take its place, but we're going to have to color that to red. So that's what you see here. Okay. Now, so once we finish that, we're going to have to go down to the one of those 4 cases, right? So if you read the case number 3, okay, so I kind of copied that over here. Node X is black and its sibling W is also black. So we had to, I wrote the, W here and X there, they're sibling and they're both black. If X is a left child, no, that's not it. If X is a right child, right? W's right child is red. Okay, you have to go back and look at these diagram here, make sure that we get correct color there. And the W's left child is a black. So this is what we want, because if you go back to the diagram here, okay, X is the right child of 11, so that's what we have, and W's, okay, right child is red. In this case, the red 6. And the W's left child is a black, because the nil is going to be always a black here, right? So that's the case 3 of a second condition there. So for that, we're going to have to do a color W's child black. Okay, I'm going to show you the diagram down here. Okay, give me a second. It's kind of slow. Okay, color W's child black. Okay, so that's what we did, right? If you, and the color W red. Okay, now when you look at the first conditions there, color W's child black. If X is the left child of color W dot left black, if X is a right child, color W right black. Okay, so in this case, if you look at the, I didn't write the X over there. Okay, so if you look at the diagram over here, we're going to color W's child black. And that's what you see here. W's child is a black. And then we're going to color W red. And that's what we did here. All right, now this is going to get a little bit more complicated here. Now, next thing here is that we're going to rotate the W. Okay. Now, there are conditions here which, when you rotate the W, which one is it? Is it going to be X is the left child to do a right rotation? If X is a right child, do a left notation. So now if you look at the X is going to be where the X is going to be the right child of 11. So we are going to rotate the W, okay? Let me see. If you go back up here, if X is the right child, I can't even say it. Okay, let's look at this. That's the second one here. So if X is the right child, then we're going to do the left notations. So we're going to have to do rotation this way, right? Rotation. Okay, so we're going to rotate this. Now remember we went over the rotation on the previous lecture video there. Okay, so that means, okay, now let's just make sure that what we are doing here. So when you rotate, okay, you have to be careful on on the rotation there. Now here we are rotating the W, not X over there. So we are not doing anything. Okay, this rotation is going to be for W. Okay, so because that's what we have there. We are not, rotating X or 11. We are rotating the W. So if you rotate the W, okay, then the 6 is going to come up, 1 is going to go down. And, oh, sorry. Here is the 6. Okay. And here's 1. So as you can see, if you're going to rotate this, okay, then, we already finished the rotation there. Sorry about that one. I'm just not going to confuse you for this thing here. So after your rotation, as you can see from on the top over here, 6 is going to come up and then 1's going to go down, and that's what you see there. So now, after the rotation, if you go back up to the directions over here, then now we have to change the W. Okay, so if X is a left child of a set W, then the set, then W is going to be X dot P, right? So this is what we're talking about here. Okay, so it's going to be either one of these two cases here. So if X is a left child set, okay, then the W is going to be X dot P, parents right. If the right child, then it's going to be X dot parents left. Okay, so when you look at the this diagram here, now remember the X is going to be the right child set. So W is going to be X dot P left. Okay, so meaning that the W, the letter that we are using is going to be the whatever that you have, it's going to be the left child of its parent. So the parents of 6 is going to be 11. So now the W becomes the left child of that 11. Okay, and the X is going to be still on the right. So after you finish this, now we're going to have to go down to the case 4. That's what we, directed to. So after you finish that, we're going to go down to the case number 4. Okay. So the case number 4 says if the node X is black and its sibling is black, we went through this already. And if X is a left child, W is the right child, and so on. So for this case, number 1, okay, color the W with the same color as a parent. So now, right now, the W is going to be red. Okay. So the we are going to same color, which is the what is that? Parent. Okay. So if you go to the previous, 11 was the red color. So now we're going to have to paint the same color, or yes, W with the same color, 11. So it becomes red. Okay, this is after, if you look at this diagram here, this is the after we did all these 3 steps. So before this diagram, if you go back up here, okay, the parents of 6 was red, 11 was red. So we're going to have to color the same thing with the parent color, which was a 6. So that's where you see 6 over here. Okay. Now then, color X parent black. So the X's parent was 11, but it was the red before. So now it became black. And the color W child black. Okay, because if you go back up to the diagram here, the W's children was red, right? So we're going to color that black. Okay, so that's what this guy was. So this is the 3 steps that I did everything at one after the other, and this is going to be the diagram that we ended up with. Now then, after that, we are going to. So let's see how this one over here. I'm just going to make some adjustment here. So this is not colon. This is going to be the comma x dot p. Okay, and same thing over here. Somehow my computer's a little bit slow here. And same thing. Okay. All right, so we are going to let's see. That's what we did. 1, 2, 3 step over here. Okay. Now we're going to have to go down to the next step, number 3. I'm just going to correct this one here. Okay. All right. So we're going to have to find out whether we're going to look, color this thing here. So if X is the left child, then the color W right, black. Okay. If X is going to be a right child, then color W left, black, which that's what we did. Now we are going to rotate the X as a parent. So now the X is right below 11 there. And we are going to rotate to the right because that's what we say here. If X is the right child, do the right notations. So that's what we said here. So if you do the right notation for 11, so 11 is going to come down, then 6 is going to be going up, and 1 and X is, 1 and 11 is going to be the same level here. And W still we have on 6. Okay? So then after that, we are done. So when you look at the red-black tree property, so you meet all their properties here. So this is the more difficult case than the other cases that we have looked for. As I mentioned, when we go through these conditions, first, initial conditions with the two categories, and then you will come down to this one of the four cases. If you meet the criteria, otherwise you're just going to finish it. We will do some more exercises for deletion here, but I do not want to get into more complicated than more complicated than the one we just did here. So this is going to be the most complicated deletions that we're going to have. All right. So we'll do some more practice when we meet in person, which will be the Monday, and at the time, we can go over this together and ask me some of these questions. But because we are not using the Python algorithm for doing this, all I'm asking you here is that I want you to understand doing these operations based on the instructions that you're given. Okay, so this is the same as the insertions on the red-black tree. You're just going to have to go through some of these cases. Then based on those cases, you're going to either rotate, add, delete, whatever. Okay, so you're probably going to need these instructions. I'm probably going to upload it in these case the instructions, and at the same time we have recording for this lecture here. We have a link for that, so anytime that you can go back and take a look at this again, if you need to go over this again, that would be a great idea. Okay, so unfortunately I don't think you can print this. I don't know why, but Microsoft whiteboard, you cannot directly print this. But there is the share link that you can use, and I think I made it available for you guys to access my whiteboard here. Okay, so that shouldn't be any problem. Then again, you can always go to the Zoom recording. If you prefer that, you can just rewatch this and look at the whiteboard if you need to. Okay, so we'll do. I don't want to spend too much time on deletions here. As long as we have a good understanding on one of the last deletions, then I'm okay with that. I am more concerned about the adding deletions. I'm adding nodes rather than deletions. Okay, but again, red black trees. Okay, it's one of the balanced trees. Okay, so we also have the other two types, binary tree and the 2-3 trees. So this is just another way of balancing the trees. Okay, so I still want you to understand how to delete a node from the red-black tree as well as the other trees, but I want to put more emphasis on inserting a node rather than deleting it. Okay. All right, so we'll come back and look at this a little bit more next week, and then we're going to move on to the hash table. Okay? All right. I'll see you in class next time. Okay? All right. Bye-bye.